that. So welcome to the session on 24 reasons to love your Sharp EL-W506T in the technical maths classroom. So we're going to be going through a ton of reasons why the EL-W506T is awesome, and I'm going to demonstrate that with the calculator as well. So I'm not going to go through the list now because we are going to cover everything. And reason 25 is the home button. So home just allows you to go from any other mode back to normal mode, which is a nice time saver. Then we have 8 different, in fact 9 different modes that you can use. So equation solver is another reason 26. We're going to cover it tomorrow in the IB section. And reason 27 is the drill mode, although with technical maths. So reason 27 is the drill function, which I was saying, and that basically is just a mental maths practice function. So you can play with it when you get the calculator. The other reason that it's awesome is you can download the simulator for free. So what I will do is just share this presentation with you at the end in the chat function, and then you can click on this link and directly download the simulator to your PC. So the first one that I want to show you is a shortcut for class marks. So basically, if you have a test, and let's say it's out of 70, for example, and you want to convert all of your marks to a percentage out of 100. Now you can change that. So if you wanted to convert your class marks into something out of 40 or something out of 30, depending on your CAS requirements, then that's where you would put it in the numerator. So we're just going to do a percentage out of 100 because that's quite common. And then at the bottom, you put the total that your test or assignment is out of. So we said it's out of 70. Then you multiply by your first student's mark. So first student got 40 out of 70, and we say equals, and they give us 57,14, 57%. Then for your next student's mark, say your next student gets 55 out of 70. All you would do is type in 55 and press equals, and it gives us 78,57 or 79%. Then we can also say 63 out of 70, and so on and so forth. So you can just keep typing in your student's mark, and it will just give you marks and your percentage straight away. So it's very nice, save you a lot of time in the classroom. So there's all of the instructions for you. Now the next thing that I want to show you is the stats function, and this is useful both from a student perspective as well as from a teacher perspective if you're doing class marks and stuff and you want to find the average of your class and so on. So you press mode and then 1 for stats, and we choose 0 for single data, and you get this list here. So you just type in data. I'm actually not going to use the example because my example has got 14 different data points in, and that's a lot. So I'm just going to make up some stuff here. So you just type in the number and press equals after each value. And there we go. Okay, so once you're done, you can press change, and that will take you to your calculation screen. If you want to go back and edit the data, you just press change again. If you want to change something, so I see I put 14 in, and I should have maybe put in 41. So what I would do is use my arrow keys to highlight the 14, type in 41 instead, and then just press equals, and it will just overwrite it for you. So then once you have done that, you can just press change. Now to find all of your statistics values, it's very easy. You just press the blue key, which is alpha, and you can see in blue above 8 it says stat. That's your statistics menu, and then all you have to do is press 0, and then it will give you a summary of all of your stats values. So your average, which is 61,4, your standard deviation, which is 26, your sum of x, which is 553. So that's if you want to show your steps. And then of course you've got your 5 number summary. So your minimum, median, and your maximum, and then of course quartile 1 and quartile 3 as well. So it's quite a nice one. If you want the individual statistic because you want to do a calculation, then you can just choose 2, 3, or 4, depending on what you're looking for. So obviously 2 will give you your average and your standard deviation, and then 3 will give you the sums, and 4 will give you your 5-number summary. So if I wanted the average, for example, I could just press 1 and then press equals. Or what I could do is, if I wanted to do 1 standard deviation from the mean, I could say alpha 8 and then choose variable again and choose my standard deviation, which is 4, and say equals. And then of course I can go back and edit that and make it a plus so that I can see my range. So that's stats is a really nice way, and it's a really nice way of doing stats on the Sharp calculator. So here's another example for you that you can just follow along and try out as well. Then of course we also have linear regression, which is really, really nice. So again, I'm not going to use the example because firstly, the story doesn't make sense, but secondly, it's got like 10 data points you don't need. So I'm just going to press mode and 1 for stats, and then choose 1 for linear regression. And you can see the a plus bx is your linear regression line. So you can put your data in where you type in all of your x's first, use your arrow keys, shift over to the y column, type in all your y values. But I find a lot of times that I make mistakes when I do that. So I would expect students to make the same mistakes as me. So what I like to do is actually type it in as a coordinate pair, because it really is actually about the relationship between your x variable and your y variable, right? So to do that, we type in a 1 or whatever your value is, or your x value is. You use this x, y button, type in your y value. I'll just make it 3 and press equals, and you can see that it then goes across the table like so. Then let's do 2 x, y button and 9 and equals, and 3 x, y and 15 and equals. I think it's a perfect straight line, but we'll find out in a sec. Okay, so once you've put in all of your data values, obviously you're going to use more than 3. I'm just doing 3 just to give you a demonstration here. And then press change. And then again, we use alpha and 8. And here we've got the 1 for regression value. So we're just going to press 1 for regression values. And then we've got our y-intercept, which is -3. Our gradient, which is 6, and you can see it's a perfect straight line because your correlation coefficient is 1. So all of those values are there for you. You've still got all of your normal regular statistics, which is there for you in your summary page, but you also then have the linear regression line as well. Great. Any questions? We're all good so far. If you do have a question, just pop it into the chat function and let me know what your question is. So we have this wonderful table mode that we've now added to the W506T. And so let's use that. So we're going to press mode and 2 for table. And I'm using just a basic example of a hyperbola here just to demonstrate something. But for finding fact pairs, you know how difficult it is to factorize trinomials for some students. So this is a really nice method. We have done a whole workshop on factorizing trinomials, and that's on our YouTube channel. You can go and watch that after this one if you want. I'm kidding. But yeah, it's a really nice way to teach factorizing trinomials. So what you do is you type in your number that you want the factor pairs of, press your fraction button, and then next to your fraction button, type in RCL. So press RCL twice and it makes an X. You can also, of course, press alpha and RCL, but I'm lazy, which is why I use RCL. It will give you the same thing, which is X. Once you're done, press your equals button. Ignore function 2 for now. We'll come back to it. I'll show you a couple of really nice applications. Press equals, and there at 0, you can see your asymptote. So your asymptote actually looks like an asymptote or a stripy line. So when your students see, okay, that X is 0, I have a stripy line at y, it means I must draw a stripy line on my graph. There's all of your factor pairs. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 and 7.2. So we know 5 is not a factor because it has a remainder. And then 6 and 6, and obviously 7 and 5 again shows that we've finished all of our factors. But what's really nice about the table is that it's completely unlimited. So you can really go for as long as you like without running out of space. And even though we started at 0 on a long way to make a point, but I'll come back. Even though we started at 0, it doesn't matter where you start because you can go up as well. So you can go back into the negative side of things and look at those factor pairs or whatever values, coordinate pairs, depending on what you're doing with your table mode. But you can see your table really is unlimited. You can go for as long as you like without running out of space, which is pretty awesome. And it makes teaching things a lot of fun. So I'm going to show you some of those things in a sec. But let's go back now quickly to some new functions that we've added. So we're going to look at prime factors. So I'm just going to press home, and home then just takes me back to normal. You can see why it's a really good reason to like calculator. Home makes things a lot easier. So let's say, for example, you wanted the prime factors of 96. So you type in 96, press equals, and then just say second function and exp. You'll see in orange above it, it says p fact. And there we have it there. So we have 2 to the power of 5 times 3, which actually turns out to be quite a nice prime factor example. Then we've also added a highest common factor and a lowest common multiple, which is really nice as well, particularly for teaching factorizing. And of course, algebraic fractions as well. So if we wanted the highest common factor of, let's say, 96 and 48, so we can say second function and 2 for GCD. GCD stands for greatest common divisor, which is exactly the same thing as highest common factor. Then we type in 48, and we say equals, and magic, it gives us 48. What's really nice here is that you can have as many numbers as you like in this list. Okay, so I can add 36 and I can add 12 and so on and so forth. And then it will give me my highest common factor of all of those numbers. And you can do the same thing with lowest common multiple. So obviously the minimum number is 2, but you can have as many as you like there as well. I'm just doing 4 at the moment, but I've tested it out with lots, I think up to 16 different numbers. So you really have a lot of choice here and options for this as well. Okay, so that's prime factors, highest common factor, lowest common multiple. Now I want to show you lots of different things with time, which is a really nice one to have, particularly for technical science as you go into degrees and radians and all of that stuff as well. I should have done radians first. Hey? We'll get to radians, don't panic. So there's 4 different ways that you can deal with time. Sorry, I just want to actually check. Okay, so if the first one is if we wanted to convert 470 minutes into hours. So we could say 0 in the place of hours, press your DMS button, type in 470 and press equals, and it gives us 7 hours and 50 minutes. Now, I did a demonstration the other day, and you can also do it with seconds. So if you put 0 in the hours, 0 in the minutes, and let's say we had 300,000 seconds, and we just say equals, and it gives us 83 hours and 20 minutes and 0 seconds, ironically enough. So it's a really nice way to calculate time very quickly. Then your other functions that you can do is if you have a speed distance time calculation, then you can say, for example, if I drive 780 kilometers to Carnarvon for change, and then you did an average speed of, let's say, 103 kilometers per hour, and then we say equals, and it gives us 7 hours and 57, so about 7.5 hours approximately, but we can check that by saying second function and DMS. So it gives us 7 hours, 34 minutes, and 22,136 seconds. Now, the other nice thing that you can do is also say I have 95 hours and I want to convert them into seconds or into minutes. Then I use just my math button, and then I can choose, okay, I want to convert 95 hours into seconds. So I press 1 and it gives me that. Or I can say 95 into minutes. So I press 2 and it gives me 5,700 minutes. So it's a really nice way to do time calculations. Then the last type of time calculation that you can do using the calculator is just a basic, how long were you in a space for? So if you started something at 9:45 and it ended at 12:15, how long were you busy for? So you can say 12 DMS and 15 for 12:15 minus 9 DMS for 45 for 9:45, and then equals, and it gives us 2.5 hours. And then of course you can again change the way that it looks using second function and DMS to give you that decimal setting or notation as well. So that's all the time things. I keep forgetting. Any questions? Are we all happy? We're good so far. Please do, if you have a question, pop it into the chat or into the Q&A. I'm happy to answer both sides of things. Just let me know. Okay. So this shortcut is particularly handy because when we start thinking about complex numbers and all of that fun stuff, this makes a big difference, right? So if your coordinate pair, so we're talking grade 10 to 12 math here because we're talking technical maths, right? So if we have a P coordinate, which is 5 and 12, and we're looking for R, right? And the angle theta. Okay, so what we can do is just type in 5 as my x coordinates, press my x comma y bracket button, and then press 12, and then all we do is say second function and 8, and you can see above it, it says arrow r theta. So it's actually converting it from rectangular to polar coordinates for you. Then you can also convert back. So if I have the hypotenuse and my angle, I'm just going to make it up. And we press second function and 9, it will give us our x and our y as well. So it's a really nice shortcut for Pythagoras and trigonometry as well. Okay. So there were a couple of requests in the comments section for calculus and integration and differentiation. So I'm going to show you that you can actually do differentiation at a point. So very important. It's not going to give you an algebraic answer in the sense of x and y's and so on, but it will give you a value for whatever your differential is at that point. Okay, so to do differentiation, you can see above the close bracket button is a little ddx. So we use it, and it's blue. So we use alpha and the close bracket button, and it gives us our differential. Then again, to type in an x, you can either just press RCL twice or say alpha RCL as well. It's up to you, whatever makes you happy. Let's just type in, see. Like so. Okay, so we've got x squared minus 3x to the power of 4, and we want to know the differential at the point where x is equal to 3, for example. So then we would just fill in 3 and press equals, and you can see it gives you this long value because it's actually using an approximation technique and not actually an algebraic technique. But most of the time the answer is 100% correct, so don't worry about that comma, comma, comma. Obviously the answer is negative 318. Then of course you can also do an integral. So that's on this button. So again, we use our alpha and our open brackets, and then you just fill in your start of your integral. So let's say -1. Then at the top, you can fill in till 1, for example, and then again you're just going to fill in whatever your x is. your expression is, and you can put in trig equation stuff if you want as well, although this is not going to make sense. And you'll see it says busy when it's working hard, and then of course your answer at the end as well. So it's a really nice, again, it's a definite integral, it's not an indefinite integral. You can't do infinity and all of that stuff, but it's definitely nice for checking your answer. So most calculators that are in this range have differentiation and integration. So it's good to know how to use them and make sure that you can check your differential and integration answers as well. Then, of course, we also have a complex numbers mode. So to get to that, we press mode and 3 for complex. Then you have your I, which is just pressing the DMS button, like so. And then there's a whole bunch of stuff. You can do the conjugate of your values. So you can say -5 plus 3i, and that will break it down for you. You can find your real and imaginary numbers and so on. And what's also really nice is you can see there's a little XY here. So that is given to you in your rectangular coordinates. So we can also convert it into polar coordinates pressing second function and 8. And again, you can convert it back again by saying second function and 9. So it's a really nice, quick and easy way to convert between the two different ways of writing in your complex numbers. I don't think there's much more to say about this. So that's just a very, all of these slides are just a very in-depth breakdown of the complex numbers that we're doing. Okay, great, fantastic. So let's talk binary numbers. That's interesting. So on the calculator, we're going to go back home to normal mode. We continue recording. Awesome. So binary. So it's very, very easy. With binary, you just type in whatever your decimal number is, and then you can convert it by pressing second function. And you can see on the divide key, it's got the, why is it giving me hassle? Let's just say second function in binary. Don't know why it's hacking down. Let's try a smaller number, and then we'll go from there. There we go. Maybe it just doesn't like such big numbers. And then you can obviously just type in any binary numbers, add them together, and press equals. And then you can convert back again by saying second function and equals to give you a decimal answer as well. So really nice and easy to use the binary system on your calculator. Then, of course, you can also very easily convert between degrees and radians. So let me show you quickly. So let's say, because we're already in degrees mode, you can see that here at the top of your screen, right? So let's say you wanted to convert 30 degrees into radians. So the way to do it is to press second function and your DRG or decimal, and then it will convert it for you. Then if you want to go from radians into degrees, then you could just say second function and your decimal, and again second function and decimal. Now we have a very nice D1, D2, D3 shortcut key. So basically these save your favorite functions. So that's a bit of a schlep if you want to do lots of conversions quickly, is to press second function dot the whole time. So you can actually store that into a D1 key like so, and then say second function and DRG. Now, if I want to go from 65 degrees into radians, I can just press D1 and then it will automatically convert it for me. Or if I want to go from sine pi over 6, you see, or I wanted to convert pi over 6 into degrees, then I can just say D1 again as well. And then, of course, when it gets more tricky, you can use your DMS button or second function DMS to do the hours, minutes, seconds questions as well. Now we have a very awesome recurring decimal function. So that's it's really cool. So let's say, for example, you have 78 divided by 7, right? Which is going to give you 11 and 1/7. and I can change that and it gives me a decimal. If we press second function and setup, then you can see you've got this menu, and if you press down, you've got recurring decimal, decimal points, and name. So name, which I should have actually added as a reason, is really cool. What you can do is actually create your, let me show you. So all you would do is use your up and down arrow keys to select your letter. So I'm just going to put my quick name here. I am. And when, there you go. And then like so, right? So obviously you can't put in a formula. It's just the alphabet and then a certain dot, comma, and numbers. And then you press equals. And then when you switch off your calculator, it will just have your name underneath the Sharp, which is really, it's just a fun little gimmicky thing. Anyway, back to recurring decimal. So second function and setup. And then, so that's name. Decimal points is if you want to change between a dot and a comma. So it's an aesthetic, just to make you happy. If that's something that you prefer, then you can choose a comma instead of a dot. We're going to go to 5 for recurring decimal, and then we're going to choose 1 for on. And now when we press change, you can see the recurring decimal is actually written in its recurring format. And then if you press change again, it will give you the full 9 decimal places behind your whole number as well. So it's a really nice, just a nice little function to turn on with your calculator as well. What's also really nice, before I forget to share with you, is you can change the way that your answers are displayed. So I often get asked, can I have my answers displayed in decimals first, instead of having to press change, or whatever the other one is? So yes, you can. So you can press 2 for editor, and then remember, line is like the old calculators where it has the little R for your fraction, you know, and everything is written on one line. That's line. And then you can press 0 for right view, and you have exact, which is how the calculator comes. So it will give you your answers as a fraction or a third, or with pi in it first. And then, of course, if you have approximate, what will happen is if you have something like a decimal answer required, it will give you your decimal first, and then it will give you your fraction as well. So we'll first give you the decimal answer and then the fraction answer. It's just a preference thing. I'm going to go back to thirds because mostly we work with third answers. So you just press setup and then right view and then exact again. Otherwise, what you can also do is reset your calculator by pressing the little button on the back as well. Okay, so that's that one. Then we also have a random function, which is awesome. Guys, please do jump in if you do have questions. Let me know. I feel like I'm just gab-festing here. But if you do have questions, type them into the chat. And for those who are watching on YouTube, type them into the comment section and I will answer your questions there. So we have a random function, and that's just second function and 7. And that gives you access to 4 different options. So you've got random, which is random decimals between 0 and 1 to 3 decimal places. You have a dice, which is exactly like having a dice. So it gives you random numbers between 1 and 6. You have a random coin. So instead of saying heads and tails, it's going to give you 0s and 1s. And then you have a random integer, which I'll show you now. So what this allows you to do is choose any 2 numbers that you want to generate random numbers between. So if, for example, you were doing the sum of rolling 2 dice, then you'd have your smallest sum would be 1 plus 1, which is 2, and your largest sum would be 6 plus 6, which is 12. Oh dear, I lost my calculator. Apologies. There we go. So, and then we could type in 12 and press equals. And then if you keep pressing equals, it will generate random numbers for those as well. Great. So that's the random function. There's lots of nice things that you can do. I often play the lottery with students. So I'll generate random numbers between 1 and 52. And then I ask them to fill in their random numbers on a piece of paper, switch the person sitting next to them, and then we have a lot of fun. No one ever has won the lottery or come close. I think I had one student one time with 4 numbers. And I'm pretty sure there was some cheating involved. But yeah, it's quite an exciting one as well. Then, of course, we also have a really awesome percentages function. So if you wanted to add 15% to 120, you could just say plus 15 and then second function and 1 to give you that percentage. You can also say 120, 15% of 120. So you could just say times 15 and percent. And then if you were looking for a value before that, so say your price is 300 Rand and you want to know what it cost before you paid the extra VAT tax, then you can say divided by 115%, like so. And then that will give you 260 and 81 cents. Cool. Then I've showed you the user-defined shortcut keys already where we did it with the degrees and radians. So I'm not going to repeat it here. We also have a dedicated pi button, which allows you to just type in pi, and it's easy to find. So it's a big button on the calculator. It's right there at the top. So it's very easy for your students to use, and you can just change the value. It gives you accurate 9 decimal places as well. Then, of course, we also have logs. So let me just show you quickly how that works. So we've got a normal log, which is base 10. And then, of course, you also have a log where you can type in your own base. So we've got 2, and let's make it 32, and equals. So it's just second function and your pi button to give you the log with any type of base. Now, I did some application here because I think it's quite nice to see how you can actually use the calculator to teach different topics. But before I begin that, I do want to make a mention of Geogebra. Geogebra is such a nice tool. So this is the link to Geogebra, and then you can just download the app, and it allows you to draw graphs, and you'll see the graphs that I have here in this presentation is drawn with Geogebra. If you want to get your students to draw graphs by hand and you need some graph paper, then you can download them from worksheetworks.com for free. They have various options as well for graph paper, which is really nice. And I do recommend actually getting students to draw graphs. I think it's such an important skill to have with your students. So let's start here. So what I did is I just did a basic straight line graph because I just wanted to distill down the essence of what we want to do here. Okay, so in function 1, I just typed in an x. Okay, so in other words, y is equal to x. And then what we can go through and look at the table and you can see they are the same. So when I would draw a graph, it will look like that. So it's a straight line, 45-degree angle, so on and so forth, right? Now, what happens if I multiply that x by 2? What would happen to my coordinates and what would my graph look like? Well, you can see that all of my y coordinates have doubled. So if I drew that graph again, my first graph would be here and my second graph, let's just change the color, would look like that. Okay, so you can do this. I'm going to go back to my thing here because it's got quite a nice thing. So if I multiplied by minus 2x, what would happen? You can see that obviously all of the y's are now negative, so it's actually reflected the graph. And so when we draw the various graphs, here's my original graph. My red one is the one where x is multiplied by 2, so you can see it's steeper. If I did it with a half, for example, then it would be much less steep than my original graph. And then, of course, when you multiply by a negative, then you can see it's reflected around the y-axis. So it's a really nice way to work out how gradients work. And I've done this in a grade 10 functions study guide chapter as well. So if you're looking for some interesting ways to teach graphs or some new ideas, we've got that grade 10 study guide chapter on functions, which uses this methodology as well. Then, of course, you can also talk about shifting your graph up and shifting your graph down and seeing what happens. And you can see, here's my original graph, here's my one where I added one, and my one where I subtracted one. So it's really nice and easy to be able to compare the points and see what's going on. And then, of course, to actually draw your graphs. But the important thing here is actually seeing what happens to the graph, as opposed to just looking at numbers on your calculator screen. Then, of course, you can also teach simple and compound interest. So let's say, for example, we have 1,000 Rand and we invested at an interest rate of 10% per year, and it is compounded with a simple interest. So we can just type that in there, close our brackets, and say equals. And I'm going to just jump straight through to the compound interest as well. So there we go. And again, I'm going to use all the same values, obviously, but changing the formula. So that's my compound interest formula. Okay. Then if we go through, we can see at a zero, at the point zero, when I made my investment, it was 1,000 Rand. And after 1 year, both of my investments have an extra additional 100 Rand. But after 2 years, my simple interest has again added an extra 100 Rand. And if I go through my table, I can see I just keep adding 100 Rand each time. But if I go up to my compound interest, I can see now that this hasn't kept adding 100 Rand each time. It's added 10% of my previous amount. So it's growing at a much faster rate than my simple interest. So again, it's just a nice way for them to compare. And because your table is unlimited, you've got a lot of room for asking questions like, when does your simple interest double? When does your compound interest double? When does your compound interest double your simple interest after how many years? You know, so lots of great questions about that as well. So there's all the steps for you to follow. Then this one is really, really nice for teaching trig. And I really want to show this to you because I think it is amazing. So I'm not going to go through the actual trig equation steps because that's not necessary. What I want to show you is solving a specific equation. So here is the original equation that we started with, and we want to find values between 30 and 200 degrees, right? So there's my general solutions, negative 10.53 plus K360 and 130.53 plus K360. Now, what you do is in your table mode, in function 1, you put your first general solution, right? Plus, and then obviously instead of a K, we'll have an X times 360. And then in function 2, we'll put in our second one, 150.53 plus X times 360, and we say equals, and obviously our step stays 1. So what's actually happening is our X value is our K, and in our table we can then look for values that lie between 30 and 200, and we can see it's only that one there. Everything else is too small or too big. So only answer that matches is 130.53 degrees. So it's a really nice way for teaching or finding the specific solution, particularly when the range is a bit bigger and you're expected to substitute all of those various Ks, and then it becomes quite complex and confusing. So I thought this was quite a nice way to simplify it down without having to do all of those monotonous calculations and making a mistake somewhere on your calculator as well. Awesome, guys. So the last 2 things that I want to share with you is the Sharpies Rewards Program, which is for wonderful maths teachers like yourselves who are willing to give up time in the evenings to watch webinars. So anybody who is a Sharpies teacher will get points for the presentation of the webinar. You can exchange your points for gifts like Bluetooth speakers and laptop bags and earphones. And then, of course, if you decide to change your stationery list over to a Sharp, then you can just send me a picture of your stationery list, an old one and a new one, and then I will add, I think it's 200 points for doing that, which is quite a lot of points. So there we go. So if you want to sign up, that's the link. And then if you want to tell your friends about Sharpies, because that's what a good Sharpie would do, then that's the link for you as well. You also get points for doing that. Then lastly, you can download the simulator again for free. I think this is the W535 link. The W506 link was at the beginning of the presentation. There's a link to download Geogebra for you. And then, of course, remember Maths Sharp is for grade 8 to 12, Maths, Mathlets, and a couple of technical math worksheets as well. And then I've created my own blog, which also has maths worksheets, but it started with grade 7. So for technical maths guys, I'm sorry, not quite what you were looking for. Thank you guys so much for joining us.